Welcome to this explainer. Look, today we're diving deep into modern data architecture. We're getting hands-on with the PySpark blueprint for scalable data engineering, and I've got to say, I am genuinely thrilled to unpack this with you. If you really want to understand how the world's biggest companies are handling their massive data loads today, you are absolutely in the right place.
Just think for a second about all the apps on your phone. The massive enterprise systems running global supply chains, the smart devices sitting in your living room right now. Literally every single second, they are pumping out data. We're talking millions and then billions of records constantly. It's this chaotic, relentless flood of raw information that's just endlessly pouring in from websites, mobile apps, and IoT devices all over the planet. The sheer velocity is honestly staggering.
But wait, let's just pause here for a second. How do organizations actually make sense of all this information without their systems just completely crashing? I mean, if you try to push this massive, tsunami-level wave of data through traditional single-machine processing tools, they just break. They simply cannot handle the crushing weight of modern digital transformation.
Okay, let's dive into this and look at the actual solution to this data flood. We'll be walking through 5 key areas today. Number 1, the big data challenge. 2, distributed processing with PySpark. 3, building scalable data pipelines. 4, real-time analytics and beyond. And finally, 5, the future of data. All right, starting off with section 1, the big data challenge, and looking at the severe limits of traditional processing. Moving right into section 2, distributed processing with PySpark, or what we like to call the divide and conquer approach. When you're dealing with a highly chaotic, intensely messy data environment, you need a serious heavy hitter to bring some order to the chaos. So what exactly is PySpark? Simply put, it is the Python interface for Apache Spark that seamlessly combines Python's simplicity with Spark's distributed computing capabilities. This is an absolute game changer. It allows organizations to process extensive workloads efficiently while still maintaining critical scalability, reliability, and speed. You're basically getting the intuitive ease of Python, which we know data engineers already love, paired perfectly with the raw, heavy-lifting horsepower of Spark. And this brilliantly illustrates exactly what we're talking about. Look, traditional processing is like one single person trying to organize a massive, multi-story library all by themselves. It's incredibly slow, it's frustrating, and it acts as a huge bottleneck. In stark contrast, PySpark's distributed computing is like unleashing a highly coordinated team of 100 people to organize that exact same library simultaneously. Instead of bottlenecking tasks on a single machine, PySpark distributes the data across multiple computing nodes. They literally divide the work, conquer it in parallel, and drastically reduce the time it takes to analyze billions of records. Now, because it's built on Apache Spark, PySpark can handle practically any format you throw its way, whether that's structured, semi-structured, or completely unstructured data. It effortlessly connects to databases, cloud storage, APIs, and IoT devices. And it manages all this using its incredibly powerful DataFrame architecture. Data engineers can clean datasets, strip out duplicates, and execute some really complex transformations using concise Python code. And the best part, PySpark is automatically optimizing those execution plans right behind the scenes to maximize computational efficiency. Which brings us to section 3, building scalable data pipelines and actually transforming the chaos. Now, what's really interesting about this is that managing data isn't just about dumping it into storage. It's about building a highly reliable, continuous journey for that data to travel through. It needs to go from its raw operational source to a polished analytical asset. We break this down into an automated ETL workflow. First up, extract, continuously pulling in fresh information from diverse enterprise systems. Then, step 2, transform. This is where the actual magic happens. You clean the data, remove duplicates, and standardize the formats based on specific business rules. And finally, step 3, load, safely delivering that pristine, finalized data into data warehouses or cloud-based data lakes. PySpark provides the complete framework to fully automate this entire operation. When you stack up manual workflows right next to PySpark, the structural upgrade is just obvious. Manual processes are notoriously slow, and honestly, they're highly prone to human error. But with PySpark, organizations can pull fragmented information into a unified environment rapidly. You get these robust automated workflows that rigorously validate records and correct inconsistencies on the fly. This kind of automated validation is crucial because it completely prevents bad data from ever reaching your business intelligence dashboards or machine learning models. It ensures top-tier quality control and just streamlines the entire integration process. Let's pivot to section 4, real-time analytics and beyond, where speed officially meets AI. We are way beyond the days of just batching data overnight while everyone is asleep. The modern reality is that businesses need their insights instantly. I mean, they're dealing with continuous, heavy streams of online transactions and social media interactions that absolutely cannot wait until tomorrow. To handle this, PySpark utilizes Spark structured streaming. This feature processes massive volumes of streaming data with exceptional speed. It actually allows businesses to respond to changing customer needs, detect fraudulent transactions, and spot operational issues the exact moment they happen. You aren't just staring in the rearview mirror anymore, you are actively analyzing the road right in front of you in real time. And this right here is a real aha paradigm shift. The PySpark ecosystem isn't just a basic tool for moving data from point A to point B. It is the exact place where data engineering directly meets artificial intelligence. Within this single, highly efficient distributed environment, your data engineers and scientists can handle data preparation, execute complex feature engineering, and even build out predictive modeling using Spark MLlib. So you're doing heavy-duty machine learning directly on the distributed data without ever having to migrate it to a separate system first. It's brilliant. Finally, let's move into section 5, the future of data, focusing heavily on cloud integration and its real-world impact.
I want you to really consider the real-world stakes here and the frankly massive infrastructure needed to support enterprise-scale analytics. So the crucial point is that PySpark offers completely seamless cloud integration with all the major players: Microsoft Azure, Amazon Web Services, and Google Cloud Platform. By combining PySpark with these cloud services, organizations can scale their computing resources dynamically, meaning you don't have to sit around guessing exactly how many expensive physical servers you need to buy and maintain. You simply scale up in the cloud when you need that heavy processing power, and then scale right back down when you don't. It is incredibly cost-effective.
And look, this isn't just a bunch of theoretical tech jargon. Let's anchor this back to reality. Entire global industries are being completely transformed by PySpark right now. In healthcare, it's actively being used to analyze patient data to drive better, faster medical outcomes. In finance, it's the engine powering complex, real-time fraud detection algorithms. It is driving critical supply chain logistics in retail and manufacturing, optimizing heavy network traffic in telecom, and it's even accelerating massive breakthroughs in scientific research. These diverse, heavy-hitting industries fundamentally rely on PySpark for their critical day-to-day operational success.
Which actually leads us perfectly right into this quote from our source material. Mastering PySpark enables organizations to build efficient data pipelines, improve business intelligence, and unlock the full potential of modern data engineering. I love that because it cements PySpark's role as this absolute gold standard bridge, transforming raw enterprise data into highly strategic, actionable business value.
So, I'm going to leave you with this final thought to chew on. Is your organization truly prepared to conquer this massive data flood? Or are you still relying on that single librarian to somehow organize the chaos? It is definitely time to explore modern data engineering and see firsthand what a distributed solution can really do for your workflows. Thank you so much for joining me for this explainer, and as always, keep learning.